Hello guys, you are welcome to another video on Achievers 10 class. I'm reminding you to please subscribe to this channel. For this particular video, we are asked to calculate the tension in this string, the two strings in this diagram in equilibrium. The question says that a mass of weight 120 Newton is hung from two strings as shown in the figure. Determine by scale drawing or by calculation the tension in RA and RB. So we have three forces acting in this system. One is acting vertically downward, while the other two are inclined upward forces. Alright, so we are not going to be using the scale drawing because we don't have the means of doing that in this video. So we are going to be using the calculation method. Alright. There are two ways of solving this question by calculation. We have the first method is by the polygon of forces. By the polygon of forces. The other method is by resolving into the vertical and horizontal component. Vertical and horizontal component. So we are going to be using the first method for this video. Watch out for the next video. In the next video, we are going to be using the second method. So, but for this video, we are only going to be using the first method. Okay. In using the polygon of forces, what we simply need to do is to connect all these arrows, all these arrow lines from head to tail. We have the head of these arrows here. So you connect the three forces from head to tail. And to do that, this is what you have. The first one is the 120 Newton. The 120 Newton comes this way. That's the vertically downward force. So the arrow is here. This is the arrow head. Then the next one is the RA. Force RA. So RA goes this way. So it goes this way. So okay, let's leave it here. So the force, this is it. So this is our R, this is our RA, this is R, and R, and A. Then the last force, which is the RB, so it goes this way, so I'll use it. So that is the RB. So this is RB. So let's call them. This is RB. So let's name the length of the lines. So this is the one. This RA. While this last one, which you are given as 120 Newton. So this is the equilibrium. This is the polygon of the forces that are in equilibrium. So what we simply need to do now is to analyze the triangle. So in analyzing the triangle, we notice that these two forces, they are at right angle to each other. That is force RA and RB. So this is RA and RB. So this is at right angle. The diagram is not very perfect, but the two forces are at right angle because by the time you add 50 plus 40, it's going to give you 90 degrees. So they are at right angle to each other. That is, you can bring this particular force by the time you connect it at this point here. This is your RB. You see it's at right angle. So the first thing you need to remember in resolving in polygon forces is that all the arrow ends must join from head to tail when the system is in equilibrium. For a system in equilibrium, all the arrow ends connect from head to tail. As you can see, all the arrow ends connect from head to tail. Then now we can resolve our triangle. So you can get some other angles here, like this 120 degrees. You notice that if you should draw a line this way, you are going to notice that the angle between this line, if you draw our 120 Newton from the top here, you want to find the angle. You want to find the angle that is between them. Let's get it from this direction. From this direction, you notice that the angle that is here is going to be 50 degrees. That is alternate to this angle. These two angles, they are alternate to each other. If you draw a vertical line, so that means that this angle is equal to 50. So that means this angle is going to be 50 degrees. So this angle will now be 40 degrees. So that is how you can solve your question using polygon forces. So now, after getting all the values of the angles now, we have to get RA and RB. So to get RA, so if it's a right angle triangle, so that means the RA in reference to angle 40 degrees will be the adjacent. So that will be cos 40 degrees. That's adjacent, that's RA over hypotenuse, which is 120 degrees. So RA will be equal to 120 cos 40, and that will be, let's place our calculator. So we have cos that is cos 40. Sorry, that is 40 cos 40 times 120 Newton, and that will give us 91.93. So that is 91.93. Let's use the decimal place. So that is 91.9 Newton. So that is our RA. Then to calculate RB, we are going to use, in reference to 40 degrees, 2 is going to be sine 40 this time around. Sine 40 is equals to RB divided by 120. So RB will be equal to 120 sine 40. I will replace our calculator. That will be equal to, that is sine 40 times 120, and that will give us 77.1 Newton. 77.1 Newton. So this is how you can calculate your system in equilibrium using polygon forces. I will recommend you check the next video, the part 2 of this question, to get the other method, that is resolving into the vertical and horizontal component. Then we are going to compare our answer to the one we got by polygon forces. Thank you, and please do remember to subscribe to this channel.